Hello everyone, this is Solomon. I'm here to explain you about the implementation of doubly linked list. So, you know what's doubly linked list? I'm gonna tell very shortly again about doubly linked list. So, this is the doubly linked list here. So we have three places to store the things. So first in the middle we'll store the data, and the next two sides will store the address of the next value and previous value. So in the next list you can see here we'll have one value, and the last will be the null, and next will be the address of the previous value. So in this way the doubly linked list is there, and we'll have one start. So this start will contain the address of this value. So we'll directly go into the code. So here's my code. I've coded it. So we are defining class called node. So we are constructing here init self comma data. So you know all these details as you have seen my previous video. So class, we are declaring another class here. So real list. So define init self dot head equals to none. So if we want to insert the element in the beginning or end, we can do anything. So this is the process for the beginning. So to insert in the beginning, we need to do, we come here to the diagram. If I want to insert in the begin, so if I want to insert here, so first what I need to do, I need to copy this address and I need to store in the new node what I am attaching, and this to be connected here. Just a second, I'll explain. So this address will be stored here and this will be connected here, and this address need to be taken and stored here, and this address, the address of this point need to be stored here, and this need to be connected here. So in this way this will go on. So if you see in the code how it's running, so new node equal to node data, so all to node data will be stored in new node. So if self dot head equals to none, so self dot head equals to new node. So if this is none, it will be equal to new node. The values will be here. So else if if the old node is not none, then this will comes to else part, and new node dot next equals to head dot next. So new node dot next equals to head dot next. This will take the value, and the next value and self dot head will be connected. So and previous value and next value will be done in the same way. So previous value we need to store in the new node, and next value we need to store in the new node. This will be taken here. So here if we see new node dot next, this value will be stored in self dot head, and this self dot head equals to new node. So all this data will be shifted to new node, and self dot head dot pre equal to new node. So this also will be taken here and define init. So here comes we need to, sorry, so here comes insert at end. So if you want to insert in the beginning here or insert at the end, so in the same way we will do. So new node equals to node dot data. So if self dot head equals to temp equal to self dot head, while temp dot next, so if it can go to the next, or if the value what, if you want to attach the new node in the end, what need to be my condition, it should be the null value in the last, then only I can attach a new node. Because if it have the some value or some other address, so it refers to there is some more nodes in the front, so that is not the end. So the case or the condition what we need to have with insert end is like last node should be have null value. So insert at the end. So while temp dot next equals to this next value, it will keep on checking, so as it should be null value. So if it is a null value, then it will store the value at the end. So else self dot head equals to new node. And I'm not reading this code, just I'm explaining what's the concept, that's it. So try to understand. So insert at some position. So if you want to insert the element at some position, not in the beginning, not in the end, so this is in the middle at some position. So if I want to insert a new node at the beginning, so I, I said how to insert element in the some position. So how to begin at the end? So this null value should be stored here, and the address of this value will be here, and the address of this value will be here, and the start value will be connected here, and this will be the null value. So in this way the doubly linked list works. And the same way, inside at some position, we need to have mainly two things. First, we need to copy the address of the previous node two times, and we need to place in the new node, and we need to join the new node to the old nodes. So if key double equal to 0, this is exactly the position. So key double equal to 0, self dot insert begin. So this will go and work insert begin if self dot head equals to temp equal to self dot head, while temp dot next equals to insert at end, inserts at position. So self dot insert begin temp equal to self dot head p equal to 1, while temp p is less than key. So we are checking a condition here. P, the value p is 1, and p should be less than key. What is the key? Key is 0. So this condition fails, and it comes out of else part, because p is 1 and key is 0. So 0 is not greater than p. So if p is less than key, then index out of range. So this case will come when it exceeds the more values. So if it is not a true, when p is equals to key, then self dot next equal to new data, then it will return new node dot next equal to temp dot new. So new node dot previous equal to current one, and all these things will be returned. And deletion, and to delete some elements, so we know how to delete some elements. We have discussed in queue and stack all the things. So it will keep on checking the condition until the number is found, and there it will remove the element. So deletion, first element will be removed. Normally when we take in these cases, the elements in the beginning will be removed. First inserted element will be removed first in the queue, and first insert element will be removed last in the stack. So display, so we need to display all the elements what we have. So if head dot self dot head equals to none, list is empty. If it is none, it will list is empty. Else the elements are, so p equal to self dot head, all the elements present here in the p will be there printed. So print p dot data and p equal to p dot next. So we know all this. This is just for the user, for user to know him. Print 1 to begin insert, print 2 at insert at end, and print 3 insert after, print 4 delete, and print 5 display, print 6 exit. So if you press 1, it will insert, it will go insert begin. If we press 2, it will go insert end. If we press 3, it will go insert it exact data where you want to do. If you enter 4, it will what we want to delete, and if we enter 5, it will display. So let's run the code and check how it's gonna work. Yeah, we can see the out here. So first I'm gonna enter 1, and I'm gonna enter 10. I'm gonna enter 1 again, 20, 1 again, 30, 1 again, 40. So now let's display and see how it will be displayed. I'm sorry, 405 has been printed there. It's not a problem. So let's check. So 405, 30, 20, 10. So if we enter some data, if I want to enter it end at the end, so it should be here. Okay, enter at the end. It should print come here, not here. So let's check. Insert at end. It will be 2, and I have stopped at 40. Now I'll go with 50 and 60. I'm sorry. Enter your choice, 2 and 60. So let's check how it printed. Yeah, we can see here 405, 30, 20, 10, 50 and 60. So I want to insert at some position. So between this position, let's see out 3 and took 50. So enter the data to be inserted. I want to enter 55. So when we see the inbox is out of range, it should be the values we as we checked here. As we checked one condition, it will come as out of range. Uh, where is it? Yeah, if p is greater than key, so our value is 50, 55. 55 is greater than key, then it comes out and it prints as in index out of range. So let's delete some values. I'll go with 4, and now let's display. Sorry, enter the index to be deleted. Choose the function 5. Okay. So something went wrong. Sorry for that. Just wait, I'll fix it and solve it again. When we check here, so I have re-entered the values as I got some error. So now let's display. So I've re-entered every value newly. So up to 10, from 10 to 50, first order I have entered insert at begin, and from 6 to 80 I have entered insert at end. So I have displayed. So let's remove some element for uh, enter index to be deleted 3, choose your function, displays 5. Yeah, I'm facing the same error again. Let me solve it. Yeah, my error was the element what I was expecting to be deleted. It's continuously printing when I am allowing it to be printed. So that's what my error. So again, I'm printing everything. So let's check my output. So 130, 140. I'm sorry. So 140, 150. So I'll insert it at end. So to 40 and 50 completed 60 to 70 to 80. So let's display it and see. So yeah, we can see all the outputs what I have decided. So in this way we can implement the doubly linked list and inserting it, begin inserting it and inserting it some position. So hope you have understood. Thank you.